Basically, this is a very rough impression of some of the areas I'm going to be covering in this lecture. I'm not going to be covering them in this strict order because all of these things do overlap, but these points will all be touched on throughout my lecture today. Now, the main topic of this lecture is climate change. Now, if the scientists are anywhere near correct, then this is the greatest challenge facing humanity today. It is the greatest challenge humanity has ever faced and probably will ever face. It is a challenge that if we don't meet it, then future generations will have a quality of life way below that we ourselves enjoy. Now, those of you who were here last week will have seen an excellent lecture by Professor Stuart Hazeldine, and the basic subject of which was that we have the technology. It exists. We have the technology that we would need to reduce carbon emissions without losing the energy that we rely on. This technology exists. It is out there. And at the end of the lecture, someone in the audience asked a very pertinent question. It exists, so why aren't we doing it? Professor Hazeldine gave a very good answer, talking about funding and tightness of governments, so on and so forth. But actually, he gave a far more succinct answer with a throwaway comment halfway through his lecture. And that comment was this: at the moment, it is socially acceptable to put all that carbon dioxide into the atmosphere. And as long as this remains the case, there will never be the political will to spend the money that is needed to develop things like carbon capture and storage to the level that will actually make a substantial impact on climate change. Why is it socially acceptable, given the damage that scientists all say that this carbon dioxide is doing? Well, the reason is headlines like this, things like this circulating on the web, disinformation. 100 reasons why global warming is natural. Comments like that appear in the right-wing media all the time. And to give you an impression of the effect these have, I'll show you an opinion poll that was taken about 2 years ago. Do you think climate change is man-made? 41% of the public said yes, 32% said that it is not proven, 8% said it's not man-made, 15% refused to even accept that it was happening. Now, this sounds bad enough for scientists, but there's 2 points I want to make here. First, have a look at the date, November 2009. This was before ClimateGate. This was before Glaciergate. 2 events that have eroded public confidence in climate change further. So these camps are likely to have expanded, and in particular this one. The second point is this was the UK. Now, we in the UK have an impartial broadcaster called the BBC. Other countries are not so lucky. Other countries have media that is dominated by right-wing viewpoints, and probably as a direct result, those countries, there are even fewer people who believe what the scientists are saying. So what I want to do is concentrate on distinctions, because you don't need a PhD in climate science to be able to tell who's telling the truth and who's talking nonsense. You simply need a bit of science, a bit of critical thinking and objectivity. But you need to see distinctions between the basic science and the advanced science, between real skepticism and denial, which often calls itself skepticism, between good science and bad science, and between science and politics. If you understand these 4 distinctions, a lot becomes clearer. However, there are those whose goal is to blur these distinctions, because if these are blurred in people's heads, then it becomes very difficult for them to tell who is talking from a point of evidence and who is simply spouting their views. So I'm going to start with the bottom one. Politics and science. Now, politics, you can take away all the party politics, all the sleaze, all the naughtiness, and what politics should be about, what it ultimately is about, is simply one question, and only one question. What should we do? That's what we elect politicians for, to answer to because we want something to be done, and we put them in office because we expect it to be done. They may not do it, but that is what politics is, whether you're talking about it in a pub or whether it's in the Houses of Parliament. What should we do? And it advances by debate, and everybody's opinion matters. If we were somehow, this room were transported to another planet and we needed to get back, we had 3 different options, we would have to discuss it between ourselves. What do we do? Now, science is very different. Science is about a different question. What are the facts? And it advances by research, producing evidence. You do not get the answer to a scientific question by debate. You get it by looking at the evidence, analysing the evidence, and so on and so forth. So if I had a question, what's 463 times 132? I wouldn't get it by asking for a show of hands for different answers. I would get it by doing the calculation. And scientific questions are always the same. To answer them, you have to do the research. And that means nobody's opinion actually matters in science. It is just the evidence. Okay, so that's the distinction. Now let me give you some examples outside of climate change. Scientific questions always have a correct and incorrect answer. We don't always know what it is, but the answer always exists. So, scientific question, are cod stocks declining? Is AIDS spread by unprotected sex? Do mobile phone masks cause illness? Would a badger cull reduce the incidence of bovine TB? Does the MMR jab cause autism? If you want an answer to these questions, you have to do the research. You have to look at the evidence. These questions do not have a correct or incorrect answer. I'm not talking about morals here. You may think this is right and this is wrong, but that's your moral opinion. So should we catch fewer fish from the North Sea? Should we be distributing free condoms? Now, say this question, the answer should be the same whether you're the Pope or the guru of free love, but they may have different opinions about this one. Should there be mobile phone masks next to schools? Is it right to cull badgers? Should all children get the MMR jab? Now, the problem comes when people who have strong opinions about one of these attempt to spread falsehoods about these. They want other people to share their political opinion, so they try, the easiest route to that is often not to debate their own position, but to spread falsehoods about the evidence. And the same applies to climate change. So these are scientific questions to be answered by evidence. How do we affect the climate? How fast will the Earth warm? What other effects will there be? What would a 20% cut achieve? And then we come to the political questions. Should we do it? How much should we be cutting? How should this cutting be done? Do green taxes work? Which countries should do most? Now, these are up for debate, and so this is where everybody should be getting involved and having their opinion. But those opinions should be based on a fair and unbiased understanding of the science. Some will use false science to try to back up their opinion. So to summarise, science can and should affect politics. Politics can never affect scientific facts, and it should never affect the reporting of those scientific facts, but sometimes it does, and that is obviously not a good thing. Now I'm going to move on now to the distinction between the advanced climate science and the very basic climate science. Because one of those recent scandals, if you understand this distinction, you'll understand the scandal and its significance, or rather lack of it. So if we represent climate science as a tree, the evidence that the Earth is warming could be the trunk, the evidence that we're causing it could be the roots. And then as we move out onto the branches, we're looking at progressively more advanced science, projected future warming, projected effects of that future warming. We're starting to bring in models now, complex models, and eventually we're trying to predict the timing of those effects. That's the twigs at the very top of the tree, and then the leaves reflect research that is ongoing now to further increase our best understanding of what's going to happen. Now, you may recall that, hang on, something's wrong. It's this. So the PowerPoint's not working properly. That's okay. Hopefully that's fixed it. You may recall the Glaciergate scandal. A clearly false statement found its way into the IPCC report that Himalayan glaciers will melt by 2035. This was extremely embarrassing and it should never have happened. But this is a mistake in the timing of future effects. It's way out there on the twigs of the tree of science. So it has absolutely no bearing on the evidence that the Earth is warming, that we're causing it. It is simply a mistake in one of the predicted effects. And the mistake is not that whether it's going to happen. The mistake was they got the timing dramatically wrong. So we can represent mistakes like this as disease on the tree. And if a tree is diseased, a good gardener will cut off the part that is diseased. And this is the role of the true skeptic. The skeptic is a seeker of the truth. The skeptic will look for errors in the science and he will correct them. That is what a skeptic does. There is, however, a very different class of person, the denier. And the goal of the denier is totally different. He wishes to destroy public trust in the whole of climate science. And they do it with phrases like this. We're like Galileo, a lone voice challenging the evil scientific consensus. If you think I'm making that claim up, I'm not. It was actually made, not quite word for word, by Rick Perry in one of the recent Republican debates. This guy was comparing himself to Galileo because he disagreed with establishment scientists. But of course, we don't remember Galileo because he disagreed with everybody else. We remember him because he found evidence to show that he was right. And that is something that the deniers are consistently failing to do. And it cuts exactly to the heart of what science is and what scientists do. So imagine you're Galileo. You believe passionately in your heart that there are falsehoods in the established science. You've got two options. You can test your theory objectively. If there's hard evidence, you find it, and then you use that hard evidence to convince the scientific community that you are right. And if you really believe you're right, then you should believe this hard evidence is there. Or you can take option 2, where you don't worry about evidence at all. You just use any old argument that might convince the public that you are right, and when the scientific community get angry with you, you simply ignore them or you attack them. So the first route, the route Galileo obviously took, is the route of the skeptic. The second route is the route of denial and manipulation. It has nothing to do with evidence. It is simply trying to foist a viewpoint on the world. And these are also the paths of good science and bad science. Good science is where you start off with a test and you go where the evidence sends you. Bad science is where you start off, I believe something, I'm going to convince people I'm right. And we can use a simple analogy to illustrate this point further. So we're going to use a detective analogy. Dr. Black lies murdered in a as yet undetermined house room within the house. There are 6 suspects, and here they are. In walks the detective. Right, I'm gonna find out who done this murder. In fact, I know who done this murder. It was that Scarlett. She's a bad sort. She didn't agree to go out with me when we were kids, and now it's payback time. So I'm going to look at all the evidence and I'm going to sift through it carefully until I find that little piece of evidence that points to Scarlett as the one who done it. And then I'm going to take that bit of evidence, I'm going to stick it in front of the jury, and Scarlett is going down. Okay, so that is the route of the bent policeman. Now, let's see the scientific equivalent. Here are 6 possible causes of climate change suggested with varying degrees of seriousness in the past. Now, I'm going to show the public what really caused climate change. I don't want it to be this, I don't want it to be that, I certainly don't want it to be cows because I like my beef. So I don't want to change my lifestyle. And if it's the sun, I'm not going to have to change my lifestyle. So I'm going to sift through all the evidence and I'm going to pick that one little bit that is going to make people believe that it's the sun what done it. And I'm going to put that in all the right-wing press, and hallelujah, any attempt to make me change my lifestyle is going to fail. So that's bad science. You start off with an opinion and you only look for evidence that supports that opinion. The reason I've represented the evidence as cherries here, as some of you may have guessed, is because there's a name for this, and it's called cherry picking. It is where you only look at evidence that supports your viewpoint and you simply ignore the rest. Some people do this deliberately. There are others who literally, they simply are blind to any evidence that doesn't support their personal viewpoint. So a good scientist starts off thinking that anything is possible. A good scientist considers all evidence equally and thoroughly and objectively and draws a conclusion. And finally, this is important, is always honest about any doubts they may have about that evidence. And you'll see this in scientific papers all the time. So bad science is not just found in climate change denial, it is found in other places too. South Africa, HIV denial has killed something like 300,000 people. The refusal to accept HIV causes AIDS. Evolution denial in America, also known as intelligent design, is very prominent. And of course there is Holocaust denial. Now climate deniers get extremely hot under the collar about this comparison. But I am not making a moral comparison here between any of these. It is not my place to compare these on a moral level. What I'm saying is that the methods employed by all 4 of these are the same. They all use bad science, they all use cherry picking to foist a view that is blatantly not supported by the evidence. And there is a rather wonderful fictional example of this as well. Those of you who know your Harry Potter, in book 5, the Ministry of Magic goes to great lengths to convince the world that Voldemort hasn't returned. And it uses these same methods to do it. So, that's the bad science. So I'm going to try and do good science here. I'm going to take the perspective of a true skeptic. And I'm going to look at the basics of climate science. Now, you can build the science of climate change on just 4 simple facts and 2 causal relationships. Firstly, carbon dioxide absorbs more heat from re-radiated light than air does. We've known that since the reign of Queen Victoria. It is not in dispute. Secondly, humans have emitted well over 1 million tons of carbon dioxide since the Industrial Revolution. You can quibble over figures, but it's hard to deny that we've been emitting huge amounts of the stuff. Thirdly, we've been measuring the increase in carbon dioxide for certainly we've known it well since 1960, and it has been going up. This is undeniable. Fourth fact is global temperatures have also been going up over this period. None of those are disputed by any rational scientist. Now, that is not the whole story, because for man-made climate change to be genuine, two causal relationships also have to be true. Firstly, the emission of carbon dioxide by humans must be causing the rise in atmospheric carbon dioxide. Secondly, this rise in atmospheric carbon dioxide, combined with this property of carbon dioxide, must be responsible for the increase in global temperatures. Four facts, two causal relationships. The facts we don't have to worry about. The causal relationships we do need to have a closer look at. So, first one, atmospheric carbon dioxide gone up because of human activity. No, say the deniers. It's not us, it's volcanoes. Well, let's have a look. Oh, don't tell me it's stuck again. Let's see if it's working. Yeah. Okay. The reality is we know how much humans emit per year. We know roughly how much volcanoes emit, and humans emit well over 100 times more carbon dioxide per year than do volcanoes. But this is not even the most obvious reason why this claim is wrong. There's a bigger one. And it is that for this claim to be true, all of this carbon dioxide that we are pumping out must just vanish into thin air. Maybe it falls through a wormhole and reappears on the planet Tharg, and yet simultaneously, for this claim to be true, there would have to have been an increase in volcanic activity, invisible volcanoes that we can't see, just happened to be during the period of the Industrial Revolution and ongoing since. That is what would have to be true for this claim to be even remotely accurate. This doesn't deter the deniers. You take one argument down and they will simply replace it with another one. For example, they're fond of saying human emissions are too small to matter. They're only 3 or 4% of global carbon emissions. Now, that is a deliberate blurring of two economic concepts, net and gross. If you talk about gross emissions, everyone in this room is breathing out carbon dioxide. Well, where does that carbon dioxide come from? It came from the plants that we ate, and those plants took it in from the atmosphere. So natural sources are in balance between emission and absorption. The oceans are actually net absorbers, but human beings, it's one-way traffic. So it's only us that can be causing the increase. Everything else, even volcanoes, is balanced by uptake. So it's only us that can be causing the increase. Well, the deniers will still say it's something else, because they'll just switch. They won't listen to what they don't want to hear, and they'll say it's something else. And this claim has surfaced from time to time, that rising global temperatures are causing the increase in carbon dioxide, not human activity. Well, once again, it runs into this very serious problem that it assumes everything we emit disappears into thin air. So clearly that part of it is inaccurate. However, it does the second part, that these rising global temperatures are not caused by carbon dioxide. This is now challenging causal relationship 2. So we move on to looking at this one. Simplified down, it is that rising CO2 levels are causing global warming. Have we proved this? Well, this is a fair question that a skeptic would ask. We know that carbon dioxide has an effect, and that the more of it there is, the warmer the planet will get, because we know the properties of this stuff. But it is a fair question to ask, could this effect be small, and could something else be having a bigger effect? Well, there are satellites up there that are now measuring light energy that is leaving our planet, and we are able to look at the spectrum of wavelengths, and scientists have been able to show that these pink areas are where the amount of energy leaving the planet has gone down. It's gone down a lot in the methane absorption area, and it's gone down a lot in the carbon dioxide absorption area. So we know that there is energy being prevented from leaving the planet in these two wavelengths that was escaping 30 odd years ago, and the only explanation that makes any sense is that these greenhouse gases are responsible. But the deniers will simply switch to another argument and they'll say, it's the sun, big hot thing in the sky. When the sun's out, it's hot, therefore the sun must be causing global warming. Again, it's a very silly, facile argument, but equally a fair, sceptical question is, could the sun be contributing? We know from this evidence that carbon dioxide is contributing to rising global temperatures. But it is a fair question, is the sun contributing too? Well, there are various graphs of solar output over the last 150 years, but they all show the same basic pattern. No solar warming in the first half of last century, and then from then on, no solar warming. Which means, when we look at global temperatures, in fact, this burst of global warming in the first half of last century, the sun was part of the cause. That is what appeared to be the scientific reality. But from 1960 onwards, the sun has not got any greater in its emissions, so there has to be another cause for this warming, and the only cause that there's any evidence for is carbon dioxide. Now, the deniers will just switch to another argument, and they'll say, but warming stopped in 1998. There hasn't been any warming this century. In fact, believe it or not, there is an educational charity called the Global Warming Policy Foundation dedicated to disinformation on climate change, and this is its logo. This graph is its logo. Now, this graph is accurate as far as it goes, but it is still deceptive, and here's why. This is the temperature graph from 1998 to 2008. It's reasonably accurate, it's not perfect. But what happens if we go a bit further back? Well, go back to 1980, it looks like that. Go back even further, and suddenly it doesn't look like temperatures are stable anymore. And basically what we've got here is another example of cherry picking. As particularly using 1998 as a starting point, that was a major El Nino year. Equally, if I wanted to really scare you, if I wanted to pretend climate change is going faster than it actually is, I could cherry pick 92 to 93, and that would give the impression that the climate is warming faster than it is. If you want the facts without any embellishment, you need to look at the whole graph, especially as climate is defined as a trend over 30 years or more. So we've seen one denialist trick, cherry picking. Here is another one, digging up discredited data and evidence. They will root around in all sorts of sources to try and find something that they can use to spin and make people believe what they want them to believe. And there's a rather fine example of this, and it concerns Warming Island. For any of you that don't know, this is an island off Greenland that used to be under ice. It is now not under ice, and around 2005, an ocean strait opened up for the first time. However, according to a guy called Patrick Michaels, it was already an island in 1957. His evidence is this sketch map, which was done out of a plane window in and or around 1957. Now, how accurate is this map? Well, let's put a few labels onto it. There's Warming Island Strait, there's Murray Island, and there's Reynolds Island. Oh, Reynolds Island isn't actually there. But never mind, because a few people are going to read this, they're not going to bother to look at the satellite images, they're going to think that Warming Island is another myth. And that's how these people operate. And this same guy has written this book, Meltdown, and this demonstrates a very, very advanced form of cherry picking, because the book is based on genuine scientific papers. but everything that it mentions are things that make climate change seem less threatening, and it fails to mention, it says extinction rates are exaggerated. It doesn't even mention coral reefs or rainforests, which are the two ecosystems most threatened by climate change. It talks a lot about negative feedbacks. These are things that slow climate change down. It fails to mention positive feedbacks. If you really want to model future climate change, you have to look at both of these with equal care. And so it's cherry picking, there's discredited science in there too, and it was funded by a right-wing US think tank. So that is another form of denial. Now, a third denialist trick is the use of false experts. And now these can take many forms. Firstly, it can be somebody who's just a recent PhD in chemistry or geology, or it could be anything, paraded in front of the media as a major climate scientist. Or it can be somebody who has no expertise in science at all, such as Nigel Lawson or Lord Lawson of Blaby, as we're now supposed to call him. And these characters will turn up in the right-wing media. They'll normally use the phrase, "I'm not a scientist, but," and by the time you've finished reading, you will doubt everything that the scientists are saying. But this guy has no training in this science. He was a very good economist, but he has no training in this. Reading this guy's views on climate change is similar to listening to these two telling us how to sort out the financial crisis. So that is the art of using false experts. Now, while we're on tabloids, there is another tabloid-related denialist claim. And it is, oh, it's just the latest scare story. There was the Millennium Bug, there was CJD, climate change is just the next one. And this is basically comes about because of the way certain tabloids operate. They want to scare you. So, there's a wolf! Your granny is doomed! Oh! And all the housewives feel a little more scared than they did before. And so that story goes past, what's worse than a wolf? It's a GM wolf! Never mind granny. We're all doomed. Oh! And the housewives go to bed even more scared. But they won't be scared for long, because the third in the tree card trick, there's no wolf! They lied to you. Those naughty scientists, those naughty government advisors who were telling you there was a wolf. There isn't a wolf. They were lying. And that's your tabloid free card trick. And tabloids basically are crying wolf all the time in order to do what they are paid to do, which is, of course, to sell newspapers. But so it's tabloids, not scientists, who like to cry wolf. And I also might remind you how the story of the boy who cried wolf actually ends. So genuine scientific scare stories are pretty rare. These are the two that were most significant, acid rain and the ozone hole. In both cases, these receded. They didn't just go away. They receded because we acted. We removed sulfates from factory fumes, we reduced CFC emissions, and the ozone hole began to shrink. So it's not that these just go away, they disappear because we acted. There is one more scare story you may have heard of concerning the 1970s. In the 1970s, they said we would get an ice age. Now, in this case, the they was a small group of scientists. And it was just a theory. It was not the scientific establishment saying this. It was one or two scientists, and it was picked up by the media. It was based on the fact that during the 70s, our emissions from factories and power stations were very dirty. And there were three pollutants in these emissions: soot, sulfur dioxide, that's what gives us acid rain, and carbon dioxide. Now, these two have a cooling effect, but carbon dioxide has a warming effect. And the scientists in the 70s, they predicted that soot and carbon dioxide would have a cooling effect, and it would cool the Earth to such an extent that we would start to get positive feedbacks, growing ice caps, tipping us into an ice age. Now, this never became mainstream, and more to the point, it was never tested because we cleaned up factory emissions. We took out the soot. We took out the sulfur dioxide. And so we'll never know if they hadn't acted whether that ice age would have come or not. It's unlikely. I can't say definitely that it wouldn't have done, but it is unlikely. The point is that our behaviour immediately afterwards made it impossible that that would happen. Now, while we're on the subject of ice ages, there is another popular denialist claim. It's just part of the ice age cycle. Well, to understand what's going on here, we have to understand timescales. There are lots of natural factors that affect our climate, but they work on very different timescales. Many of them work on timescales that are sort of way in advance of our lifetimes. And one of them is the Milankovitch cycles. It is these that cause ice age cycles. Tilts, wobbles in our orbit that very subtly affect how solar irradiation comes to us, and when all other things are equal, they can tip us into and out of ice ages. But these operate over 10,000 years or more, so we would not expect any significant effect from these within 150 years, which is the timescale we're talking about. Now, there are other things which cause global warming and cooling. Mountain building gradually consumes carbon dioxide as mountains erode. Volcanic episodes. There have been episodes in the planet's history when enormous, unimaginable quantities of magma spewed out across half a continent and lots of carbon dioxide with it. And those caused global warming episodes. The positions of the continents affect currents, they affect circulation, they can trigger positive and negative feedbacks in all sorts of ways, cooling or warming the planet, and the sun gradually changing over time, that has an effect too. Within smaller timescales, there are more things. Sunspots. Many of you will know sunspots operate over about an 11-year cycle, up and down, up and down. Solar output, we saw in that graph earlier, that can change over 50 to 100 years. It's just that we know it hasn't changed significantly in the last 50. El Niños and La Niña, 1 or 2 years, they can warm or cool the surface of the planet. Sulfur dioxide and dust stays in the atmosphere for a year or two. Volcanic eruptions, short term, they therefore cause cooling. But if there's a lot of carbon dioxide, they then cause warming. Carbon dioxide acts over up to 1,000 years, but emitted carbon dioxide, you feel the effects of it within 30 years. So basically we can eliminate the ice age cycle because the timescale for it is much too long. Now, a fourth denialist trick is the use of logical fallacies, and they use these a lot. Okay, so this illustrates one of them, and this is the claim: Mars is warming too, therefore the cause must be the sun. The logic: the Earth is warming, Mars is warming, therefore there has to be a common cause, the sun. Let's examine this logic using an analogy. Michael Jackson died in 2009. Farrah Fawcett died in 2009. By the same logic, there has to be a serial killer picking off celebrities. This commits the fallacy of correlation does not imply causation. If you find a correlation as a scientist, you look for evidence that A may cause B, or that a third factor may be causing both. But in this case, if you want to know about solar irradiance, you look at the sun, and we have. The Martian warming is not proving, but in all probability, if it is warming, it's because its orbit is far more erratic than ours, as you would expect it to be, because it's quite close to Jupiter. And of course, it ignores the vast body of evidence that carbon dioxide is causing warming. Now, this is the most popular denialist claim of the lot. the climate has changed before. And there's two versions of this, and they're both based on logical fallacies. Now, this statement is actually accurate. It's what comes next that causes the problem. So the first version, the climate's changed before, therefore climate change must be natural. So the implication, climate changed in the past, it wasn't caused by us, therefore it can't be us causing it now. Looking at this, reducing it to simple logic, event A, climate change, can occur without B, humans. Therefore, B cannot cause A. It seems tempting. However, let's look at an analogy. People died before cigarettes were invented. Therefore, cigarettes cannot cause death. That is the same logic as there. So clearly this is false. And then there is the other version of the statement. The climate's changed before, so it's nothing to worry about. Once again, let's dissect this logic. The implication, the climate changed in the past, it didn't affect us. Therefore, climate change in the future won't affect us either. Here is it reduced to simple logic. Event A did not harm B when B was not present. Therefore, A cannot harm B. And some of you have already worked out the little flaw here. It's like saying, I wasn't there when Chernobyl exploded, therefore I must be immune to radiation. And here is another analogy which cuts even closer to what the deniers are trying to say. OK, people, here's the situation. There's a huge asteroid heading for Earth. And when it hits, it's going to cause a catastrophe. But it's all right. We've got Bruce Willis and a ragtag team of misfits who are going to go up there and... Oh, hang on. I'm hearing from one of my advisors. Apparently, an asteroid this size hit the Earth 65 million years ago. And how many people died? None. Not a single human being died. OK, cancel the mission, guys. There's nothing to worry about. So, yes, the climate has changed in the past. The causes were clearly natural. But there are many things that can affect the climate, and we are one of them. And there have been, in the past, major events of global warming, and many of them caused massive mass extinctions, such as at the end of the Permian. And I believe Professor Hazeldine also mentioned the event at the Paleocene-Eocene boundary, which was also global warming and also caused extinctions. Now, another little trick, they love the medieval warming period. They absolutely adore it. But if you look at our best reconstruction of temperatures from the medieval warm period, we find that it was actually localized. There's an awful lot of anecdotal evidence about how Greenland was a lot warmer at that time. And from this reconstruction, you see that's perfectly accurate. It was. But other parts of the Earth were colder. So it's not a global phenomenon. And if we compare that graph, basically blue is colder than now, or red is warmer. Well, not than now, actually. It's relative to 1960, I believe these are. And so basically we compare the last decade to the medieval warm period, the redder, the hotter, and clearly we can see that it's a lot hotter than the medieval warm period. Another claim they're very fond of, also based on a logical fallacy, the climate is too complex and chaotic to predict, so we should do nothing. So here comes the analogy. OK, you are the owner of a china shop. I come in with a very, very angry bull. I say, right, I'm going to leave this bull in your china shop for half an hour. Bye. You say, wait, no, the bull is going to run amok and it's going to smash all my china. I say, but can you tell me which items of china the bull is going to break and in what order? You say, well, of course not. I say, well, how do you know it's going to smash any china at all? So we don't need to be able to predict exactly what's going to happen because the science is pretty unequivocal that the planet is going to war. Now, when evidence really stacks up against climate deniers, when the weight of evidence is so great that it seems that there is no way that evidence can be resisted, they have one last card to play. And it's the conspiracy card. So all of these scientists who are saying I'm wrong, they must be part of a conspiracy. And it's worth noting that the British newspaper that's most fond of climate denial is the same one that was very fond of saying that Prince Philip killed Princess Diana. Read into that what you will. But those of us who work in science know that this is rubbish. But for those of you who don't, it's a fair question. Is there any possibility that scientists are colluding to deceive the public? If you genuinely thought this, what would you do? How would you test it? Well, I'll tell you how I would do it. I would identify a major research institution that was concerned with researching climate change. I would hack into their data servers and I would download all the emails by those scientists and I would look for evidence of a conspiracy. Now, as you all know, that has happened. And the most incriminating statement, virtually the only incriminating statement they can find is this one. I've just completed Mike's nature trick of adding in the real temperatures to each series for the last 20 years and from 1961 for Keith's to hide the decline. And the deniers simply focused on the word trick and the words hide the decline. So a denier would take this and try to spin it. A skeptic who wants to get to the truth would want to know, what is this guy talking about? What does this paragraph actually mean? And therefore, is there a deception here or not? So let's delve into this issue. And you may be surprised to learn it concerns tree rings. And it also concerns what happens at the tree line on mountains. It's all about bristlecone pines. Now, these are trees that can live 8,000 years. They can live longer than some of the Republican presidential candidates probably think the Earth has been around for. And consequently, they are very useful for measuring past temperatures. Now, this is a ring width of trees some way below the tree line. And you can see they go up and down like this. Whereas trees that are actually at the tree line, they behave differently. And the reason they behave differently is that depending where you are on the mountain, different things are limiting you. So if you're at the tree line, you're being limited by cold. And therefore, if the climate warms, you'll be able to grow more. If it cools, you'll be able to grow less. But if you're lower down, then other things are likely to be limiting. It might be drought, it might be competition, but your growth rate will track something other than temperature. So that's the first point. The second point is that we've been able to reconstruct how these things at the very tree line have been growing over an extraordinarily long period of time and compare that to various reconstructions of global temperature, and we can see that very roughly the pines are tracking temperature. But a problem arises as we get near to the present. So this is the period when we have the best temperature records from all manner of other sources, and up until about 1980, tree rings, there's a bit of a divergence here, but generally tree rings track temperature, and then suddenly they don't. And this is what is referred to among scientists as the divergence problem. Tree rings stop being an accurate recorder of temperature in certain localities that have been looked at around 1980. So logically, what we believe is happening is that in this time period, temperature is limiting, but from here on in, something else becomes limiting. Because this data is from lots of sources, many, many sources. This is from just one. It could be drought limiting growth. It could be seasonal stress. It could be global dimming. More aerosols in the atmosphere, less sunlight. We just don't know. But That is what this quote actually was about. These guys have been asked to provide a graph of global temperatures based on tree rings running from a long way back up to the present, and they knew that from 1980 tree rings ceased to be a good recorder of temperature, and they were forced to insert temperature from another source. They were urged to do that by the publishers. But this is not anything sinister. It is just publishers wanting to make things simpler than they really are. But let me assure you, there has been no attempt to hide this divergence problem. This is a review paper from 2008 talking about the divergence problem, and there are 13 references cited in this paragraph alone. Now, if you're running a global conspiracy, you don't publish 20 or so papers about it in the public domain. So if this is the closest evidence that they've been able to get to a conspiracy, we can safely conclude there isn't one. So I want to talk briefly about the concept of consensus, because this is another thing that people misunderstand. And the deniers like to say that if you don't agree with the consensus, you don't get funding. Well, that's not strictly true. I'm going to tell you how science should work. You've got a lot of guys believing one thing and a few guys refusing to believe it. And in climate change, it could be what's causing climate change. Most people believe it's humans. Most scientists believe that, because that's what the evidence says. But there's a very small number of guys on the fringes who think it's the sun, cosmic rays, or volcanoes. And now this is not unhealthy. It may surprise you to hear me say that, but this is normal in science, that there will always be people who disagree with the consensus. It's what they do with that opinion that is important, because nobody is standing still. Everybody is trying to find evidence to increase human knowledge. And another point to make is that these guys in the consensus, they don't all think the exact same thing. They're all strongly independent minds, and it just so happens they agree on certain things because the evidence for those certain things is so strong, but they'll disagree on the likely speed, the effect of clouds, and all sorts of other things. And over time, science changes. And it usually changes because somebody discovers something a little bit new. So there's something, it supports the general consensus, but it changes slightly how we see it. And if there's sufficient evidence, then that discovery will be accepted by most or all of those within the consensus, and scientific opinion will move on. That is how science advances. Now, very, very rarely, something comes along that overturns the consensus. Maybe once or twice a century, something is discovered that is so radical that it completely overturns it. And it's often somebody who previously accepted the consensus. He was trying to find out more about this, and instead he learned something that couldn't be reconciled with the consensus. And if he has enough evidence, then sooner or later that opinion will spread and the consensus will be overturned with a new consensus. Equally rarely, a maverick, he is actively seeking to overturn the consensus. He's seeking that bit of evidence that will prove, for example, that the sun is the major cause of climate change. And if he's seeking hard evidence, he's following the path of a skeptic, and he's hoping that if he finds it, then the consensus will be overturned, because these guys will make their minds up based on evidence. However, some maverick scientists avoid proper scrutiny, and there's two easy ways to do it. One is to write a book, and Ian Plimmer is probably the worst offender of these, and rather than going through peer review, you simply put your views into a book and sell it. There are plenty of people who will fund publication. Or you go to the right-wing media and you parade yourself as a top scientist, which they'll be only too willing to do, and then they'll believe that climate change is wrong. So these mavericks are an important part of science, but they have to behave like a skeptic in order to advance science. It is how they behave, not the views they hold, that determine whether they are advancing or retarding science. Now, I'm going to finish by examining briefly some of the causes of climate change denial in people's minds. And the first one is the fear fallacy. And I have some sympathy for this, but only some. It is a really horrible thing to consider what we're doing to the planet. And David Bellamy, my childhood hero, clearly simply could not accept. He'd spent his life trying to conserve plants, and along comes something so big he can't fight it. So he seems to have chosen not to believe it. Now, there are two fictional parallels for this. One, once again, comes from Harry Potter. Cornelius Fudge, the Minister of Magic. He just cannot accept that what he has built up is threatened by the presence of Lord Voldemort, so he actively denies it. The other fictional parallel is that fear leads to anger. Anger leads to denial. Denial is the path to the dark side. So that is the fear fallacy, and it's probably the reason why a lot of the public simply do not want to accept climate. Nobody wants to accept climate change, but as a scientist, I have to believe what the evidence tells me. The second fallacy is the economic fallacy. It's too expensive to deal with climate change, therefore it can't be a real problem. This is like saying, I've got £2, the bus fare is £3, therefore 1 + 1 = 3. Now, economists are interesting because it's a weird science, economics, if you call it a science, because what people believe in the world of economics actually shapes reality. If everyone believes that Greece is going down the toilet, markets will drop and Greece goes down the toilet. If everyone suddenly believes that Greece will be okay, markets go up and Greece rallies. So it's easy to see why economists are seduced by this idea that what they believe can become reality. Now, thirdly, there's the political fallacy. Dealing with this requires regulation and green taxes. It's against my philosophy, so I deny it. And if you look at climate deniers across the media, you'll find that with very, very few exceptions, they are right-wing. In Britain, it's UKIP and the BNP. That's the right-wing press. And America, it's the Tea Party. You look at almost any country in the world, the most right-wing party almost invariably are climate change deniers. And finally, there's the astronomers' fallacy, which is they study astronomy, they know that celestial effects can affect the climate, and they then assume that celestial effects must be the only cause. That's the logical equivalent of saying a dog has 4 legs, therefore any animal with 4 legs must be a dog, even if it's a cat. So that is the astronomer's fallacy. So I'm going to end by reiterating these distinctions here and adding very briefly 2 more. It's really an extension of this one. A scientist states facts about climate change. The job of scientists is to tell you what is. The job of an environmentalist is to urge action. So scientists comes from a merely information-giving viewpoint. These guys are taking a political viewpoint. But in the right-wing media, you'll constantly hear them saying that it's environmentalists who originated the idea of climate change. It is not. It came from scientists. Environmentalists are simply telling us we should do something about it. So keep this distinction as well. Finally, and this is important because many of you will go away and debate with your right-wing uncles about this. It is important to distinguish between those who invent and spread these falsehoods, and they're generally very intelligent people. They know that they're making it up, and they're usually making a lot of money. But most people who don't believe in climate change are ordinary folk who have read a lot of this and they've believed it, often because, obviously, it's much nicer than not believing it. So these people must be treated with respect. And so I shall finish with this simple cartoon, which I believe represents the current situation we're in. And if you want to know more, I suggest you go to this fantastic website. And what do you know? the PowerPoint has broken again, so I'll just... And I'm happy to take questions. Please work. Okay, well, you'll have to just squint to read it because it's not playing at all. Thank you very much.
I promised you entertainment. I said that we should have erudite conversation. I think we had that. We went through astronomy, forestry, politics, a whole range of disciplines in a superb introduction, a superb definition of the difference between skeptical science and deception. As Richard said, we're happy to take questions. The only thing I ask is, because the proceedings have been recorded, if you can wait for a microphone. There are 2 microphones coming round before you ask your question. So can we take the first question, please? Stunned by the presentation. Here's one.
What motivates these people?
That's a very, very good question, and I think it probably varies based on the individual. Those at the very top are motivated by money. Some are motivated by conviction. There's a very interesting bit of research that indicates that people with right-wing viewpoints have a larger amygdala, which is the part of the brain which produces emotions. So some people form their views based on emotions, whereas others form them based on evidence. And if you form your views based on emotion, you're liable to form, I don't like this person, so I don't believe what he's saying. I like that guy, so I believe what he's saying. And so, I mean, there's a whole plethora of things. In the case of David Bellamy, it's fear. And people like Nigel Lawson may actually genuinely believe they're acting for the best. If you can first convince yourself that climate change cannot be real, then you will passionately believe that you are defending the economy of your country by telling everyone that it's not real. And these people can be very convincing. I mean, I remember, it's a bit off topic, but I remember watching Tony Blair arguing for the war in Iraq. And he clearly, passionately believed that it was the right thing to do. While I was watching him, I almost believed him too. And of course, once I came away, my logical side kicked in and I knew it wasn't correct. But the point is that there's 2 stages to denial in a lot of people. The first is the subconscious filtering out of unwanted information, and then a viewpoint forms and the person believes they're acting for the best by promoting that viewpoint.
What about people who believe it's true but fail to do anything?
Well, that's now we're into the area of politics rather than science, and so it's that's I can only sort of talk about that as a human being rather than as a scientist. Now, as a human being, I clearly think that we desperately need to act. I want to be a parent one day, but beyond that, I want to speak for all those people, related to me or not, who'll be around in 100 years' time. But that is only my opinion. But I do believe that the more people believe this, that the more likely they are to act. So I suspect that there's also, denial can operate on many levels. You can sort of believe something factually, but not believe it deep down in your heart. And so if you say, oh yes, I accept climate change, but you just won't allow yourself on an emotional level to think about what is going to happen to the planet in the future, then you can sort of separate your everyday life from what you believe in the more academic side of your mind. So I think that there's some of that going on. But equally, going back to the very start of my lecture and Professor Hazeldine's comment, it's socially acceptable at the moment to pump carbon dioxide out. It's socially acceptable to have a private jet. And so I think whether we realise it or not, we are all influenced by what is and is not socially acceptable.
Hi, thanks. That was a really, really good talk. Not that I'm accusing you of cherry picking, but have you come across any creditable evidence that global warming isn't due to CO2 emissions that we've given out?
Not really, no. I don't, I accept the possibility that that evidence may one day be found, but I've never seen any sort of claim to the contrary that did not fall apart upon scrutiny. It may be that because I've encountered so many stupid denialist arguments, and this is an interesting point actually, there are so many of these nonsensical arguments out there that it is possible that someone somewhere has found a real flaw in the science, but that flaw is subtle and complicated and nobody's noticed it because of all this nonsense being talked by the louder voices of deniers. All I can say is I've never seen anything that casts serious doubt, but I'm only one person. I can't promise you it isn't there.
Hi, how long do you think we have before it becomes socially and otherwise unacceptable to emit carbon? And how radically do you think we have to act consensually?
Right, well, I think it's, the more we act, the better things will be for future generations. There's all sorts of estimates, and basically, if we do a huge amount within the next 10 years, we will still face quite an uncomfortable future. The less we do, the worse it will get. But I don't know exactly how far. There's not agreement on how much we need to do, how fast. To be honest, I don't think there needs to be, because the one thing I am certain of is that we will not do as much as the scientists say we need to do. That's why I've never sort of looked that closely at that particular question, because what the scientists say we need to do is over here, what we're currently doing is way over here, and what various global agreements have tried to get us to do and often failed is somewhere over here. So the gulf is so enormous that it's a perfectly fair question, but for that reason, I've never really looked at it in that much detail. I think that in many ways, changing social opinion is the most important thing we can do at present to deal with this problem, because then people might start moving towards what the scientists are saying we need to do.
Hi, thank you very much for the talk. I was here. I was very interested in the point that you made about the ClimateGate scandal, where all those emails were sort of leaked and, so to speak, cherry-picked information was reported in the tabloid media. I was just wondering, it seems to me that the way to check whether or not the information in the tabloid media was true would be if more people had access to peer-reviewed journals, but the vast majority of these are pay. You can only view an abstract for free, and to read the article you have to pay actually quite a lot of money, which is beyond the reach of the general public.
I think that's something that scientists should seriously think about changing. I completely, unequivocally agree with you about that. It's difficult because the only way I think to achieve it would be to have a universal levy on scientists, probably through universities or governments, that supports scientific journals. One way, there are some journals where scientists are expected to pay to get their papers into those journals. Journals are businesses. Some of them only publish online, which makes it cheaper. And maybe the more do that, the better. But somebody's got to edit the journal. So, but it's it is a question. I agree with you. I think we have to find a different way of funding research papers.
Hi, thanks for the talk. It was really great. But I was wondering, when it seems like more often than being asked simply, is climate change real or not? For the purpose of policy, the scientific community has to provide a kind of a range of effects they think are probable given 1 degree, 2 degree, given a certain amount of carbon. How do you think the scientific community should go about presenting that? And how do you think sort of skeptics and your tree of science feeds into those more delicate predictions?
Well, scientists, I mean, the whole point of that research on those far branches is to give the best estimate we can of the data we currently have of what is going to happen. The important bit, the most important point, is that there have to be error bars. Virtually any scientific estimate of a number will come with error bars. So a good estimate will have a range. So if we take this particular path, worst case scenario, it will warm by 6 degrees by 2100. Best case, it will warm by 2 degrees. Now, obviously, that's an enormous range, and deniers have been known to get hold of these and say, my God, these scientists have no idea what they're talking about. And I've heard comedians saying a very similar thing, or mock the weak. But honest science, that's how it operates. Now, if I were presented with best case 2 degrees, worst case 6 degrees, I wouldn't worry about the error bar. I would be very scared because 2 degrees is bad and 6 degrees is apocalyptic. So the very best case is bad. So, I mean, I think scientists need to present data very accurately. Accurate means with big error bars, but I think also they need to be perhaps better at explaining why those big error bars are there, explaining that they are there because they're taking into account negative feedbacks and positive feedback. They're taking into account water vapor. They're taking into account clouds. These are things that are difficult to predict exactly what they're doing. And scientists need to communicate that better to politicians and to the public. Does that answer your question? Or feel?
Yeah, I was also wondering, I mean, when you talked about skeptics, and then obviously, I mean, so then with those skeptics then, do you think, I mean, it's often the scientific community is quoted, but obviously there's a whole range of opinion there.
There are, yes. I mean, the IPCC is, it's not a whole load of people agreeing, it's a load of people saying, oh, it's this, it's this, it's this. It's just that nearly everybody thinks that we are warming the planet. They disagree about how fast it'll happen. They disagree about whether negative or positive feedbacks are going to be more important. And so consensus is really trying to get an opinion that is somewhere in the middle of what everybody is saying. And again, I don't think that's been communicated well enough. The idea that consensus is just a load of people agreeing, except for that guy over there who's saying something different. And and of course, every scientist is a skeptic. Every true scientist is a skeptic. I believe in man-made climate change because the evidence demands it. That is the skeptical position as I see it. And as I mentioned earlier, it is healthy to have people who don't believe the consensus and are searching for evidence that overturns that consensus. And again, I think the public need to understand that these people are there, but if they have no evidence to back their views, they shouldn't be writing books or appearing in the media. They should be looking for that evidence to prove themselves right.
Okay, we've got time for 3 very quick questions. Sorry, there's somebody behind you actually who I think was there first. I think take that. Then there was a lady here and then a lady at the back, and then I think that's as much as we've got
time. Given how well you understand how and why the... Over here.
Sorry. These two microphones are really confusing.
Given how and why the media misrepresents science, how do you feel about the disconnect between the science, as you described at the beginning, as an independent and pure objective field, and the sort of language used by the scientists involved in ClimateGate as using trickery and...
Well, I mean, the word, I mean, it's a fair point, but the word trick means different things to different people. And it means something different to a magician than to a confidence trickster. I mean, the scientists involved use trick as a sort of a way to fix something. Trying to think of an analogy, another use of the word trick. But it's not a trick as in a deception, it's a trick as in this car isn't working, but if I thump it here, then it goes again. And you could refer to that as a trick. And of course, what one scientist says to another in private, that email was never intended to be read. It was only intended to be understood by the person who read it. So it uncovers a thought process, but those two men understood trick as a fix to a problem rather than a deception.
Can we make the questions and answers fairly quick? One back there, then one here.
I'm intrigued by your distinction between a scientist and an environmentalist at the end. And I was wondering whether you can suggest an intelligent and safe way of combining the two. And if not, which camp you're in tonight?
Well, I'm in both. I mean, we all wear many hats in our lives. I'm a husband, I'm a lecturer, I'm a researcher, and when I have time, I am a environmentalist, I'm a gardener, I'm a plant hunter. So I think one just has to keep clear in one's mind sometimes the distinctions, that we all have different roles, but we understand that sometimes I'm talking as this, sometimes I'm talking as that.
Okay, thank you for the talk. And one more question. Here I am. Just do you believe we can prevent it? Because you said we are right in the middle from what we are supposed to do and from what we are doing now. So do you believe that the climate change can actually be prevented? And if not, then what?
Well, we can't prevent all of it for the simple reason that the carbon dioxide we emit now starts to have a major effect in 30 years' time. So even if we completely stopped carbon emissions today, the planet would continue to warm for 30 years more. What we would do, we're trying to slow it down. But those of you who are here for Professor Hazeldine's lecture, he showed that we have the technology to actually start putting carbon back underground. So we can't prevent all of it. How much of it we can prevent depends on how bold we are, how much we're prepared to do, and that in turn is going to depend on changing social opinions.
Well, thank you very much, everybody. I'm sorry that not everybody had opportunity to ask a question. It's the usual thing. A flurry comes at the end, just as we're running out of time. In answer to one of the questions, actually, about journals, you might like to know that and I was desperately looking for the date, and having a senior moment, I couldn't remember it. But the Royal Society of London is actually looking at science as a public enterprise, and how we actually get that scientific information out that the public, through their taxes and other routes pay for, and how we actually communicate not just the data, but the information that science contains. And there will be a meeting at the Royal Society of Edinburgh. So if you go to the Royal Society of Edinburgh website, there is a meeting shortly looking at that particular issue, and there will be a public debate on that. So that's worth knowing. But that's not what I was primarily standing up to say. It was actually to thank Richard, I think, for a very engaging as well as entertaining talk on what is probably one of the most serious issues that we're actually facing internationally at the moment. And I know that Richard's passionate about communicating this, not only because of his natural interest, but I think as a spokesperson for the generations as yet unborn who actually need people speaking about this now before they face the far more serious effects than we are doing currently. So with that, can you thank Richard in the usual way?
This production is copyright the University of Edinburgh.